This is Math 1115, Remote Delivery for April 13th, and this is the coverage of Section 6.1 content. This is Part 2. Part 1 you should have looked at already. Make sure you pause, rewind, and stop the video as you go through. We picked this discussion up with the formula for the difference of perfect squares. So if we start on this side and do distributed, we have a times a is a squared. Then we have plus b times a. And we also have minus a times b. And we have minus b squared. So you see the plus ab and the minus ab will cancel out one with another, and we will have a squared minus b squared. So this is called multiplying, go from the left side to the right side, but it's called factoring, going from the right side to the left side. So this is a formula and a pattern you want to commit to memory, and you will see it often in the balance of this course. So here's an example. And here we're taking 2x plus 5 times 2x minus 5. Well, right away you realize that this is of the form 2x plus 5 times 2x minus 5, so the 10x in the middle will cancel out, and so you'll get 2x whole squared minus 5 squared, which will be, when you simplify it, 4x squared minus 25. The second example is this one, where apparently this has to do with forces on a beam. But here you have L minus A, and here we have L plus A. So when you multiply these two things together, you will get L squared minus A squared. And then you will distribute the FA across, and you'll get FAL squared minus FA cubed. Again, this is about finding the product. Now let's talk about factoring, going the other way. Suppose we start with x squared minus 16. Then we want to realize that 16 is a perfect square, that is 4 squared. So this is of the form x squared minus 4 squared. And so from our form and pattern that we're looking at, this is going to be x plus 4 times x minus 4. Example 8, we're starting with this expression, and notice that this thing where I'm putting the pointer is 2x whole squared. So that is a perfect square. And likewise 9 is 3 squared. So this is 2x whole squared minus 3 squared. And so this is of the form a minus b squared. So this factors in to a plus b times a minus b. This is 2x plus 3 times 2x minus 3. In the same way, if we were looking at y minus 3 whole squared minus 16x to the fourth, we'll realize certainly this first term is y minus 3 times y minus 3. That is a perfect square. But this term also is going to be 4x squared whole squared. And so what will happen is this can be factored then into, this is a squared minus b squared. So this is going to be a plus b. This is going to be a minus b. And then there's really not much simplification going there, so that's what we get. And this again was a key to doing the problem. Here we're talking about the directions being factoring completely. Now sometimes you'll have to do multiple steps, and that's important to realize. So let's look at this one. Here we have 20x squared minus 45. Well, the first thing one might realize is, oh, I can factor out the common factor of 5, but then what I will have is 4x squared minus 9. But 4x squared minus 9 was one of the things we studied in an early example, and so that is going to be 2x plus 3 times 2x minus 3. Let's look at another example. Here if we have x to the fourth minus y to the fourth, we realize that this first term is x squared whole squared. The next one is y squared whole squared. So this is going to be x squared plus y squared times x squared minus y squared. Now x squared plus y squared, as they say down here, that is prime. You see x plus y squared is not equal to x plus, it is x plus y times x plus y, so it is x squared plus 2xy plus y squared. There is a middle term. It's prime. You cannot factor that. And so that one just sits there. But the other one is x squared minus y squared. It is a difference of perfect cubes. So that is x minus y times, or x plus y times x minus y. This is something that has to do with circular solar cells, but we're looking at 45 big R squared minus 20 little r squared. Now it's important to realize that big R and little r are different objects. So what I can do is I can factor a 5 out of each of those, and when I do that, I will have 5 times, that is 9 big R squared minus 4 r squared. But 9 big R squared is 3 big R whole squared. And this other one is 2 lowercase r whole squared. So this can be factored further using the difference of squares. This is 5, this is 3r minus 2, and big R, 3r plus 2r. We also can do a technique that's called group factoring. In group factoring, we have 4 terms, so we're going to look at the first 2 terms, group them together, and the second 2 terms, group them together. This is what we started with. We grouped the first 2 together and the second 2. Now here I can pull a 2 out of here, and here I can pull an A out of here. But now look what happens, and that's why I was saying that you always, the first and last thing you do in a factoring problem is look for the greatest common factor. We see that x minus y is a factor here, and x minus y is a factor here, so I can pull that out, and I have x minus y times 2a plus, or excuse me, 2 plus a. Let's test your understanding with some problems. I'm going to ask you to consider problem number 24 in the direction shown here. Hit pause now. Let's see how you did. Okay, you should have factored out the 3a and concluded with 9ab minus 9b minus 8b minus 3, as it says here. Let's try another one. Here you to factor completely. Let's do number 42. Hit pause now. Let's see how you do. So you factor out the 7 and you're left with 4x squared, which we know is 2x whole squared. And here we have 100y squared, which we know is 10y whole squared. So this will factor into 7, 2x plus 10y times 2x minus 10y. Let's look at number 54. We're supposed to solve this for K. This is like the FM problem that we did on the for the radio frequency in the content 1 for this. So solve this for K. Hit pause now. Let's see how you did. So we solve this, and we collect the terms with K on the same side. We get this after we distribute. We can factor out the K and divide by this, and I end up with K being 1. One more problem. Let's do number 62. Hit pause now. Let's see how you did. Okay, well, it is 4 terms, so you're going to do group factoring. So we group these 2 and this 2 together. Now out of here you can factor this as a difference of perfect squares. This is 4p whole squared. It's 2p whole squared, and this is q squared, so that factors into 2p plus q, and this is 2p minus q, but I had 2p plus q here. So you see 2p plus q is a common factor, so I can pull it out. I get 2p plus q times 2p minus q, and then it's plus 1, and the plus 1 comes from here. Now, more than ever, time is precious. Each day must count. Do the math, it'll make you strong. And now more than ever, take care of each other. See you in